Let us see worksheet questions of dual nature of radiation and matter. Statement 1. By increasing the potential difference between cathode and anode continuously in a photoelectric experiment, the photo current always increases continuously up to some extent. After saturation once occurs, then it will be stopped. So partially true statement it is. Next, if two photons A and B of energies 2.5 electron volt, 3.5 electron volts respectively fall on the metal surface, work function 2, both will emit electrons. Then the ratio of maximum kinetic energy emitted between A and B is 3. Okay, ratio of maximum kinetic energies. For second statement we will check. Second statement, kinetic energy of first one and kinetic energy for the second one. Kinetic energy is work function, incident energy minus work function, incident energy minus work function. Incident energy is 2, okay, 2.5. 2.5 minus 2 by 3.5 minus 2, that is equal to 0.5, this is equal to 1.5. That is 1 by 2, 3 by 2. So 1 by 3 is 1 by 3. He said 3. Okay, the maximum energy needed by an electron to come out of metal surface is called work function of the metal. Correct statement. Third one is correct one. So the first one, by increasing the potential difference between cathode and anode continuously in a period photoelectric experiment, the photo current always increases continuously, not always increases continuously up to saturation limit. So first one can't be accepted. Second one, he asked ratio of maximum kinetic energies of the two A and B. We got 1:3, but he is telling 3. So this is also wrong statement. And this is also wrong statement. Next, maximum energy needed by an electron to come out from the metal surface. Minimum energy needed to come out is known as work function, right? This is maximum. Read very carefully. So this is also wrong statement. So statement 1 is wrong, 2 is wrong, 3 is wrong. So option D is correct. In a photoelectric experiment, the wavelength of the light incident on a metal is changed from 200 nanometers to 400 nanometers. Lambda 1 is equal to 200 nanometers and lambda 2 is equal to 400 nanometer. The decrease in the stopping potential is close to, that means HC value 1240 he is trying to ask to use, and anything is given, nothing. Okay, stopping potential. Okay, he didn't give that work function or threshold wavelength or threshold energy. Is that missing? Let me check from the book. Even in the book also question is as it is. So we will try in the simplification, it may be cancelled. See, we have stopping potential EV or kinetic energy is equal to given energy hc by lambda minus work function energy hc by lambda naught. That means stopping potential V1 is equal to hc by E into 1 by lambda 1 minus 1 by lambda naught, and V2, the other one, hc by E into 1 by lambda 2 minus 1 by lambda naught. So I can write V1 minus V2 or the difference. So V2 minus V1, if we can do like this, V2 minus V1, then what happens? Subtraction, right? Then 1 by lambda naught will go. Then definitely I can write it as hc by lambda, hc by E into 1 by lambda 2 minus 1 by lambda 1. Okay. On substitution, 1240 only he asked to take. By E value, hc, obviously then E value no need to write, into 1 by lambda 2 in angstroms, 4000. Okay, 2000 here I have to write 2000 minus 1 by 4000. So this is going to become roughly 3.1 volt. The value of Planck's constant if the slope of the graph of stopping potential versus frequency of incident light is 4 into 10 to the power of minus 15 volt seconds. What is that? The graph of stopping potential versus frequency of incident light is if the slope of, okay, stopping potential stopping potential by frequency nu is equal to 4 into 10 to the power of minus 15. Okay, what is he asking? Value of Planck's constant. Slope is given. Slope is equal to, if it is the graph, this is frequency and it is stopping potential, graph will come like this, and this is theta. Tan theta is equal to, I can write the equation, H nu is equal to H nu naught plus E V naught. So V naught is equal to H nu minus H nu naught by E. So slope is equal to H by E, right? Slope can be equated to H by E. So I can equate this to 4 into 10 to the power of minus 15 is equal to H by E. So H is equal to 4 into 10 to the power of minus 15 into 1.6 into 10 to the power of minus 19. So 4 16s are 64 into 10 to the power of minus 34. Yeah. So don't give your known value. Whatever you get here, that only you try to take up. Okay. Next. Which of the following statement is not true? Electromagnetic radiation is made up of particles called photons. Each photon moves. Not true. Each photon moves with the speed of light. Correct. Photon energy in vacuum. Photon energy is independent on the intensity of radiation. Photons are not deflected by electric magnetic fields. Photons are not deflected by electric magnetic fields. This is okay. Photon energy is independent of intensity of radiation. Photon energy depends upon frequency only. He said it is dependent on. So obviously option C is wrong. Yes. This is in vacuum should be added. Otherwise this is also wrong statement. Next. In a photoelectric experiment, 3 different lights are used. Metal work function 1.5. Light A 200 nanometers. Okay, work function he has given that 1.5 electron volt, and A light is giving wavelength 200 nanometers and wavelength of intensity 1.8 watt per meter square, and B light is 400 nanometer 1 watt per meter square, and C is 600 nanometer and 0.5 watt per meter square. Which graph corresponds to which one? So on analyzing this, we can see that more current is with more intensity. More current is with more intensity. So first one, second one, third one is the order for intensity. Okay. Next. And more stopping potential with this. C 600 nanometer should have more stopping potential. So C should have order we have to set. Okay, first A light, A B C, A B C D. I think some more options are there. No. A light third option, third one. A light third one, B light second one, B light second one, and C light fourth one. 600 nanometers light, more wavelength, less stopping potential. This is less stopping potential, more stopping potential, and very high stopping potential. Because of wavelength has increased, energy decreases, and more intensity, more current. So option D. Yes. When the energy of incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from the metal surface increased by 0.5 to 0.8. The work function of the metal is equal to incident energy H nu, equal to work function plus kinetic energy K1 I can write. Kinetic energy they gave, so K1 value will substitute 0.5 electron volt. 0.5 electron volt. and if it is 120 by 100, if it is increased 20%, then this is changed to 0.8 electron volt. Okay. Now if I divide one with other, what will come? On dividing one with other, I can get 10 by 12 is equal to W naught 0.5 by W naught plus 0.8. So 2 table 5 times, 2 table 6 times. So 5 W naught plus 5 into 0.8 is equal to 6 W naught 6 into 0.5. So this will be W naught, and this will be 5 into 0.8 minus 6 into 0.5. How much it will be? 4.0 minus 3.0. So it is 1.0 work function, electron volt. A beam of photons with an energy 10.5 electron volts strikes a metal plate. The photoelectrons are emitted with maximum velocity. V maximum is equal to 1.6 into 10 to the power of 6 meters per second. The work function of the metal is, work function W naught equal to how much? Okay, we can have half mv square. Half mv square is kinetic energy. Will come in joules. If you divide with E, then it will come into electron volt, right? So in that aspect, we have to divide with E so that it will come in electron. So kinetic energy in electron volt is equal to, kinetic energy equal to half m 9.1 into 10 to the power of minus 31 by charge of electron 1.6 into 10 to the power of minus 19 into V square 1.6 into 10 to the power of 6 square. So 1.6 one time will go, and its calculated value I have. Let me take it. This is 7.2 electron volt. So work function is equal to given energy minus kinetic energy. Given energy is 10.5 electron volt and kinetic energy is 7.2 electron volt. So its subtraction will be around 3 point something. 5 minus 2 is 3 and 10 minus is 3 electron volt. A particle of charge q, mass m, energy E, de Broglie wavelength lambda. For a particle of charge 2q, 2m, 2e, de Broglie wavelength will be, de Broglie wavelength lambda is equal to h by p, that is equal to h by square root of 2m ke. So E I used, m I have, and charge is not here, so no need, any one only you have to think. So we will think only in this aspect. That means lambda dash is equal to h by square root of 2 into 2m into 2k. So dividing one with another, lambda dash by lambda is equal to, lambda dash wala will come 2 downwards and lambda wala will come 1 because on cancellation. So 1 by 2, 1 is to 2, implies lambda dash is equal to lambda by 2. Next, the energy should be, energy that should be added to an electron to reduce de Broglie wavelength from 1 nanometer to 0.5 nanometers. Lambda is equal to h by square root of 2m ke. Initial one is 1 nanometer is equal to h by square root of 2m k. Second one is 0.5 nanometer, that is equal to h by square root of 2m k2. Then divide one with other, so that what will come, 0.5 is nothing but 1 by 2. If you divide one with other, 2 is equal to, this is square root of k2, this is square root of k1. So squaring on both sides, 4k1 is equal to k2. Final energy, the energy that should be added, so what I can say is delta k is equal to 3k. So 3 times of k must be added, then you will get that story. Yeah. If an electron has an energy such that the de Broglie wavelength is lambda is equal to 5500 angstroms, then the energy value of that electron is energy equal to how much? Lambda is equal to h by square root of 2m ke, right? So here 5500 square by, why should I, let us reduce the number of steps. This is lambda square equal to h square by 2mk. Then k is equal to h square by 2m lambda square. Now let us substitute h. And the substitution and on simplification, I have the value 8 into 10 to the power of minus 25 joule. Just substitute. And it is here into 10 to the power of minus 10 should be taken here. A light wave of wavelength lambda 1 is equal to 600 nanometers. And lambda 2 is equal to 200 nanometers. Incident on a metal surface. The maximum velocity of photoelectrons produced due to one wavelength is maximum velocity of photoelectrons produced due to one wavelength is 1 by 3 times of maximum of the other one. Then the work function is equal to. So we'll write equations like this. Small wavelength, this one only corresponds to high velocity, high kinetic energy, more kinetic energy. This one corresponds to low kinetic energy. Anyway, we'll write in terms of HC, options are there. So incident energy is HC by lambda. HC by lambda incident energy is equal to work function plus kinetic energy half mv square. The other one is HC by lambda 2 is equal to work function plus, this is having more kinetic energy. So this here I will like to write, this is half mv square. This is v by 3 whole square. Come again. Second one is low wavelength. So high energy. As it is high energy, high velocity. Yes. So its velocity is v. Its velocity is v by 3. That is my sense. Okay. Now dividing one with other, and obviously one can have. Dividing one with other, HC will go. So we want HC. So not dividing, to solve in a different way. It is going to have by 9. So it is going to have by 9. What we would like to do is, if I go with here also 1 by 9, 1 by 9, 1 by 9 and 1 by 9, then what happens? Now on subtraction, minus minus minus, HC of HC can be taken common, 1 by lambda 1 minus 1 by 9 lambda 2 is equal to W naught of 1 minus 1 by 9 is 8 by 9, 8 by 9 W naught plus 0. Yes, because subtraction, we did subtraction. So W naught is equal to 9 by 8 HC by this so-called story, whatever, 1 by 1 by lambda 1 minus 1 by 9 lambda 2. So okay, next. So option will be A. The correct order of electromagnetic waves with increasing frequency R, M, I, V, U, X, gamma is higher wavelength to lower wavelength. Higher frequency to lower frequency. Is asking correct order of electromagnetic waves with increasing frequency. Yes, this is only increasing frequency. So infrared rays, X-rays, gamma rays. First one correct one. Infrared, X-rays, gamma rays. So next question. Light of intensity I is equal to 10 to the power of minus 3 and cross section area A equal 20 into 10 to the power of minus 4. This is watt per meter square intensity, right? And incident on a fully reflective surface at theta equal to 45 and force exerted is equal to F is equal to 2 times of IA by C into cos theta. So 2 into I value 10 to the power of minus 3 into 20 into 10 to the power of minus 4 by C 3 into 10 to the power of 8 into cos theta 1 by root 2. So it's going to become 9.4 into 10 to the power of minus 15 newtons. Option D. Yes. Next. Voltage applied to an electron V is equal to question mark if wavelength lambda equal to 0.5 angstroms. So lambda equal to h by p square root of 2mv So let us substitute all these things. 6.023 into 10 power 23 by root over 2 into 9 into 10 to the power of minus 31 into V into Q value 1.6 into 10 to the power of minus 19 and here 1 by 2 angstroms 10 power minus 2 10 power minus 10, or we can do in a different way also, that is 12.2 by root V is equal to lambda. Even like this also one can do. This one also will give you straight away this time taking, but V is equal to roughly 602 volts may come. Next, radiation of wavelength 300 nanometers. Lambda 1 is equal to 300 nanometers and intensity I is equal to 100 watt per meter square. Falls on a surface of a photosensitive material. Okay. 2% of incident photons produce photoelectrons. The number of photoelectrons emitted in an area of 2 centimeters square 10 power minus surface nearby. Okay. Energy of each photon is equal to hc by lambda. 12,400 by 3,000 angstroms. Now it should be, that's why. So two zeros will go, some roughly 4.1 yes, 4.13 electron volt. In joule it will be 6.6 into 10 to the power of minus 19 joule. This is energy of each photon. Now intensity is equal to total energy by area into time. Total energy is NH by area into time. But N by T is equal to IA by H nu. Out of this, only 2%, okay, 2% of incident photons produce photoelectrons. The number of photoelectrons emitted from an area of 2 centimeters square of the surface. Okay. So 2% of it is only needed. So I can write 2%, 2 by 100. So that is equal to I value, I 100, A value 2 into 10 to the power of minus 4 into 2 by 100 by H nu. That is nothing but this incident energy only. H nu is incident energy. That is 6.6 into 10 to the power of minus 19. So it's going to become 6.4 into 0.4 into 10 to the power of 14 electrons will come. If the wavelength of photon lambda is equal to 4000 angstroms, then energy will be, energy E is equal to hc by lambda, 12,400 by 4000. Two zeros will go, and it is 3 times and 4 will be 1, 3.1. 3.1 electron volt, that is equal to 3.1 into 1.6 into 10 to the power of minus 19. 3 plus into 10 to the power of minus 19 only. So it's roughly seen, right? Or you have to multiply. You need to multiply. 16 ones are 16, 16 threes are 48. Okay. Into 10 to the power of minus 9. So no guessings, only calculations. Right? Next. The retarding potential necessary to stop the emission of photoelectrons when a target metal work function W equal to 1.24 electron volt irradiated with light of wavelength lambda is equal to 4.36 into 10 to the power of minus 7 meters. Stopping potential is how much? Stopping potential is given energy hc by lambda minus work function. So its corresponding wavelength is equal to 4.36 into 10 to the power of minus 10 I want to write, so that into 10 power 3 I want to write. So it will be 4360 angstroms. So 12,400 by 4360 minus work function 1.24 electron volts. So it's roughly 3 times it will go. 3 minus almost all are close numbers only. So you need to do it. 1240 by 436. Roughly 3 times I'll take. 3 minus 1.24. So it is 1.75 roughly, right? So option C. 1.60 electron volt. All electrons ejected from metallic surface by incident light of wavelength lambda is equal to 400 nanometers. Traveled 1 meter in the direction uniform electric field for a nanometer. Traveled 1 meter in the direction of uniform electric field. 1 meter in the in uniform electric field, E is equal to 2 Newton per Coulomb, and comes to rest. Final velocity 0. This I can call as S. Then the work function is equal to how much? Work function equal to how much? So it indicates kinetic energy. So from this I can call S is equal to 1 meter. Acceleration is equal to EQ by M. Acceleration EQ by M. Final velocity 0. Then initial velocity can be obtained. That is, initial velocity is equal to V square minus U square equal to 2AS. Or S is equal to U square by 2A is enough. Why to go for all these nonsense? S is equal to U square, H equal to U square by 2G, like that. S equal to U square by 2A. That is U square by, and we want velocity. Okay. We want velocity. Okay. From this, velocity equal to root 2AS plus velocity is equal to root 2AS. That is velocity equal to root 2 EQ by M into S. Okay. And these are all known things only. Now work function he wants. Given energy minus kinetic energy is equal to work function, that is equal to given energy is hc by lambda minus kinetic energy of mv square, that is equal to 12,400 by 4,000 into 1.6 into answer is also in electron volt only. Okay. Minus half m value 9.1 into 10 to the power of minus 31. Velocity square root 2 EQ by M into S. M gets cancelled by electron energy. So this E also gets cancelled. So happily you can calculate simply 12,400 by 4,000 minus half of 2 also will go 2E into S. So 2 will go ES, 2 into 1, 2 only. So this is 2 only, this is 4, roughly 1 will come. So option 1.1A. Yes, that is equal to 1.1 electron volt. Done. Next, changing. Photoelectric effect experiment. Monochromatic light is incident on metal plate E as shown in the figure. When switch S1 is closed, how much is applied? 5 volt is applied. Cathode negative, electron anode positive. Okay. S1 is closed and S2 open. The photoelectrons strike the collector plate C with maximum kinetic energy 1 electron volt. The switch S1 is open and S2 is closed, then frequency of the incident light is doubled. The photoelectrons strike the collector plate with maximum kinetic energy 20 electron volt. The threshold wavelength of the emitter plate is, okay, here in the case 1, S1 is closed. In that case, this E is connected to positive, still stopping potential, that means electrons are liberated from E only, right? So already 5 volts you are giving, still stopping potential you needed 1 volt. So total volt stopping potential, total 6 electron volt, 6 volt. That means Hc by lambda is given. So work function plus how much stopping potential? 5 plus 1 electron volt. And whereas S2 case terminals are also reversed. So you are giving voltage to it. So Hc by lambda is equal to work function plus here 20 minus how much voltage? 5 volts. So that they will be stopped. On solving, you can get Hc by lambda value is equal to some 3 electron volt. So corresponding lambda is equal to some 4000 angstroms, because Hc value 12,400. Yes, 4133 electron angstroms. De Broglie wavelength of a proton accelerated through a potential difference 1 kilovolt. So the shortcut you can use otherwise you can do like this: lambda equal to h by square root of 2m vq, and v value is already given. H value you have to substitute 6.625 into 10 to the power of minus 34 by square root of 2 into m value 1.6 into 10 to the power of minus 27, 2mv 10 power 3, q is 1.6 into 10 to the power of minus 19. So on simplifying, you will get the answer as B. Next, 60 watt source emits monochromatic light of wavelength lambda equal to 662.5 nanometer. The number of photons 60 watt emitted per second. 60 watt source emits monochromatic light 60 watt. Power is equal to 60 watt. Number of photons. Power is equal to total energy by time. Total energy by time. Total energy is nhc by lambda into time. So n by t is equal to p lambda by hc, or p value 60 into lambda value 6625 by hc 12,400 into, you have to go for, this will come in electron volt, so you have to go for this, what you call 1.6 into 10 to the power of minus 19. Then such a big number will come. That's why 10 to the power of 20 is yes, option B. Next, the kinetic energy of photoelectrons increases by 0.52 K1. K2 is equal to K1 plus 0.52 electron volt when the wavelength of incident light is changed from 500 to another wavelength. This corresponds to 500 nanometer, and this will be another one, and which is approximately lesser than 500 nanometers. It should be less than 500 is 400. Only one option is there. You can happily select that. Then, sir, how, sir? How means you can do like this: Hc by 500, Hc by 500 nanometers it is equal to work function plus kinetic energy K1. This is Hc by, I don't know, lambda, that is equal to work function plus K plus 0.52. Solve. This is another method. Or you can simply say, as kinetic energy increased, wavelength should decrease. So only one option. According to Einstein's photoelectric equation, graph between kinetic energy of photoelectrons ejected and frequency of incident radiation. Nothing but stopping potential and frequency of radiation rate. So graph D. Work function of a metal is 1 electron volt. Work function is equal to 1 electron volt. Light of wavelength lambda equal to 3000 angstroms is incident on the metal surface. The velocity of emitted photoelectron is equal to work function, okay, wavelength, okay, velocity we want, okay. This is equal to given energy E is equal to Hc by lambda, 12,400 by 3000. zeros will go. So it will be 124 by 30. 12.4 by 3. 3 fours, 3 ones. Okay, roughly enough. Now this is electron volt. So kinetic energy Ke is equal to given energy minus work function. Given energy is 4.1 minus 1, that is 3.1 electron volt. He is asking velocity. So velocity half mv square is equal to 3.1 into 1.6 into 10 to the power of minus 19, because it's in electron volt, you need to multiply. Then velocity is 2 by 2 into 3.1 into 1.6 into 10 power minus 19 by mass 9 into 10 to the power of minus 31 under root. Then you will get the answer. 3 times will go. 3, 32, 10 times will go. So 10 for 18. 18 means 12 or roughly 13 by 2, around 6. So option can be D option. Yes, 10 to the power of 6. Roughly also you can do it. Next. Light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. Both the frequency and intensity are doubled. The photoelectric saturation current becomes. Which one is doubled? Intensity only affects the current. So doubled, that's it, not quadrupled. Proton and alpha particle are accelerated through same potential difference. The ratio of de Broglie wavelengths is proton, alpha particle. Okay, these are charge numbers, these are mass numbers. Now de Broglie wavelength lambda equal to h by square root of 2m v cube. So lambda ratio, lambda of proton is to lambda of alpha is, this is square root of v is same, qm of proton, because reverse, right? That's why here qm of alpha. So root over, I can write by division method, right? Not like this. Let me write division method, that will be better. That is equal to, this is equal to root over mq by root over mq. Whatever in the numerator, this is alpha particle, this is proton. So root over m of alpha by m of proton into q of alpha by q of proton. So root over m alpha 4 by 1, q alpha 2 by 1, 2 root 2 root 2. The number of protons falling per second is completely darkened plate to produce a force of F equal to 6.62 into 10 to the power of minus 5 Newton is N. The wavelength of light falling is equal to 5 into 10 to the power of minus 7. Then N is equal to dash into 10 to the power of 22. Here from de Broglie concept, what we have, lambda is equal to h by p. Implies momentum is equal to h by lambda. Okay, now force is equal to p by t. That is h by t lambda. This is force. F is equal to h by t lambda. Force is given, lambda is given. This is only by one photon, right? If n photons are there, then I have to multiply with n, right? So n also multiplied for n photons. Okay, let me write slowly one by one point after. This is for only one photon. Momentum of one photon. Momentum of n photon, nh by lambda. All photons. Then force is equal to nh by lambda into t. This is force. So he wants n is equal to f lambda into t by h. F value 6.62 into 10 to the power of minus 5. Lambda value 5 into 10 to the power of minus 7. Time is 1 second only. Per second only. So that equal to 1 by h value 6.02 23, okay, 6.62 into 10 to the power of 34 joule second. That is equal to 6.62 will go. So it's 5 into 10 to the power of 5 into 10 to the power of 1. Option is there. 22 obviously there. So 5 is the answer, B. Particle is dropped from a height h. De Broglie wavelength of the particle depends upon the height. Particle dropped at height causes velocity v equal to root 2 gh. And de Broglie wavelength lambda equal to h by p mv, which is equal to h by square root of okay, mv, okay, 2 gh. Lambda inversely proportional to root h. So h power minus 1 by 2. The variation of photocurrent with collector potential for different frequencies of incident radiation V1, V2 and V3 as shown in the figure. Then variation of photocurrent with collector potential for different frequencies. Okay, oh, what is this? Variation of photocurrent with collector potential, different frequencies of incident V1, V2, V3. These are all frequencies. Okay, fine. Nu1, Nu2, Nu3. Then more stopping potential, more frequency. Nu3 is greater. Nu3 is greater. Nu3 is greater. Yes, that's it. You can't tell this one because graph is not having any numbers. Find the de Broglie wavelength of electron for kinetic energy 120 electron volt. Kinetic energy 120 electron volt. So lambda equal to h by square root of 2 mk. H by square root of 2 mk. No other things. So 6.625 into 10 to the power of minus 34 by square root of 2 into 9 into 10 to the power of minus 31 into 120 electron volt into 1.6 into 10 to the power of minus 19. Okay, you happily do it. 112 picometer, 10 power minus 12 meter. Next. So end of the show. Keep on practicing.